Assalamualaikum and good evening to everyone, especially to my lecturer, Dr. Sofia binti Hamzah. Today, my group and I will present about the application of gypsum in food additive. We are from Group 8 and I would like to introduce my group members. First, we have Muhammad Nazmi bin Muhammad Arun. Second, we have Ahmad Fatih bin Ahmad Zakir. And lastly, but not least, third is me. I am Amirul Ashraf bin Zakaria.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nazmi bin Mamarun. Today I want to present about sulfate process for our introduction. So the first thing is sulfate process. What is sulfate process? Sulfate process is the main production method for making a titanium dioxide. So sulfate process also called as solid-plate process, sulfuric acid method, or sulfate process itself, and also called as sulfuric acid. Next, how to manufacture titanium dioxide by sulfate process. The iodine powder is react with concentrated sulfuric acid to produce titanium sulfate, which is hydrolyzed to form metatitanic acid and then calcined and pulverized to obtain a titanium white powder product. This method can produce anatase and rutile titanium dioxide. In sulfate process, eliminate is a common iron or titanium oxide material is used. It's treated with concentrated sulfuric acid and the titanium oxygen sulfate is selectively extracted and converted into titanium dioxide. So next, aluminate is treated or digested with a 60% excess of concentrated sulfuric at a temperature around 100 degrees Celsius. So this is the following reaction take place. Next, in the next stage, the waste product iron sulfate is removed as FeSO4 is not very soluble at low temperature. The solution is cooled to around 50 degrees Celsius and FeSO4 crystallizes out. It can then be removed by filtration. The remaining aqueous digestion products are heated to around 110 degrees Celsius in order to hydrolyze the titanium oxygen sulfate. So this is the process, another process for this stage. Next, for the last stage is the hydrated titanium dioxide is heated in large rotary kilns to drive the water and produce crystal of anatase or rutile to form of titanium dioxide. Water is removed at temperature between 200 to 300 degrees Celsius. Seed crystals are added to start the crystallization process. Depending on the final heating temperature, around 800 to 850 degrees Celsius or 900 to 930 degrees Celsius, either anatase or rutile is formed respectively. The sulfate process requires the use of very large quantity of sulfuric acid and produce copious amount of acidic waste. This acidic waste could cause significantly damage to the environment if it not disposed of responsibly. So next is about application costing input or output. First thing is normal plant operation. The only part of the process is the hydrolysis step, which is the annual effective dose received by the employee may be significant exceeding 1 msv and only when eliminate is used as a food ingredient. Next, maintenance and decontamination of equipment. There also be found a high rate of elevated gamma dose during maintenance and decontamination operations such as a worker in the hydrolysis area. Restriction on access and recording and control of occupancy provide that the proven effective to ensure safety. However, the control measure to avoid exposure pathway usually be considered. For public area exposure, the prevention step may be included with suitable step for disposal of high activity waste such as scale, rubber lining and filter clothes. In some situations, authorized may be used to get the needed assurance that is needed. In this case, both worker and public members are be maintained. Last but not least is processed material falling outside the scope of regulatory control of practice. Concentration of radionuclide activity in many solid material include the sulfate process are below 1 BQ per G and the material outside the scope of regulatory control for practice. This includes 74 titanium slag feedstock and final titanium dioxide pigment product and all byproduct except some of digester residue that produce in plant using eliminate feedstock. Some sediment, dust from off-gas filtration system and gypsum filter clothes also radionuclide activity concentration below 1 BQ per G. The regulatory body should take this into account when considering any need for future control that target at limiting the radionuclide content.
Assalamualaikum. I'm Ahmad Fatih. So I will present about the major waste generated from gypsum process. So the first thing, gypsum actually form in three types of processes. First, precipitation of nanocrystals of basanite or calcium sulfate hemihydrate with one water molecule for every two calcium sulfate units. And second, the assembly of those crystals into larger aggregate. And third is transformation of aggregate into gypsum. So we go to gypsum production process. The first is crushing. Crushing is mine gypsum or raw material enters into crusher into small particles into smaller than 30 mm. The second is screening. Screening is gypsum that follows specification will separated by controlling the diameter of sieve holes. Third is grinding. Grinding feed into the grinding mill. The finest qualified powder is clad by hydrocyclone and discharged through the powder outlet tube and transport to calcination. So after that we go to calcination. Number 4. Use the direct contact with high temperature hot flue gas of boiling furnace to complete the hydration of gypsum powder. And last but not least is storage transportation. Storage transportation send is a process of sent to the clinker warehouse for storage or into workshop to produce gypsum product. So that this is the process of gypsum production process. And now I would like to present about application of gypsum. That our group is food additive. So gypsum is the monoclinic mineral and it is hydrate whose main chemical component is calcium sulfate, that is CaSO4. Gypsum is non-toxic to human and can be helpful to animal, plant life. In fact, it is beneficial to humankind and environment when it is used for. So our our group will apply to the food additive. So the uses of our gypsum in food additive as a nutrient. First as nutrient, an additive supplement, a source of calcium. Second, as conditioning agent for water use in the brewing of beer, and as an agent to control the tartness and clarity of wine. Okay, because gypsum is considered generally safe for human, it can be used in small amounts in food and beverage production. So, food product that I will collect that may be made with gypsum include baked good, candies, ice cream, and other frozen dairy product, pudding, gelatin, pasta, and tofu. That's all for me.
I am Amiro. I would like to talk about benefit of gypsum in food additive. Gypsum is used in brewing beer and it can assist preserve the proper clarity and tartness in wine. As an additive, it assists balance acidity and improve the stability and quality of foods. It can sometimes be found in blue cheese, white bread, flour, ice cream, pasta, canned vegetables, processed fruit, dairy products, breakfast cereals, candies, soy products, baked goods, condiments, processed meat or fish, alcoholic beverage, soaps, water-based beverages, and prepared foods. Next, for the conclusion, in a nutshell, gypsum is approved for human consumption in the US Food and Drug Administration. Its use should be commercialized to the world. It can help to preserve food to last longer. This can help reduce food waste. The amount it is needed for food additive is just a small amount. It is around us and abundant on earth, so it can be used for a long time without exhausting the resource of gypsum. Even though we can, Even though we have a lot of gypsum, that does not mean we can use it as we like. Gypsum waste can be recycled eternally without loss of quality due to its chemical nature. There are 0.2 tons of CO2 emission will be saved for each ton of gypsum recycled. This way we not only reduce waste but we also can save our environment.